because of the technological barrier in entry is quite high. But looking at it from this aspect, that the climate and the environmental impact is really low if you try to generate ocean energy to the best of the current knowledge available. And there are different systems we can use to access ocean energy, which is the tidal barrage, the tidal stream or tidal current, the wave energy from the ocean, and then the ocean thermal energy conversion. And then this makes use of energy differential in the ocean. Now, so here I just talked about a bit about the ocean energy. So when you talk about the tidal barrage, you sort of create a bit of a dam-like system to be able to take advantage of the kinetic and potential energy. So we look at the ocean thermal energy conversion, where we take advantage of the potential difference in temperature, so the temperature gradient between the hot and the cold part of the water. Then you look at energy waves. So there's a lot of waves in the ocean. You're quite close to Lagos, and you can actually see that in the Atlantic we have significant waves in our ocean compared to when you go down to the Indian Ocean around Mombasa. So the waves is quite low. So based on what we have, we can actually access different forms of renewable energy, particularly for Nigeria. So these are just some renewable energy trends that are happening. So I just added these just to give us perspective that Nigeria is not just left behind. So you can see that there is the launch of a solar PV plant projected to be launched in Nigeria. And this was, so I just talked about some highlight between 2023 and 2024 that is expected to happen. So this investment is by Shell in trying to build a huge solar farm in Lekki in Lagos. So also they have the construction of the first solar cell factory in Nigeria, and this will be by Naseni. Some of you are conversant with Naseni. This is supposed to happen. I don't know the full details, but I saw this and I hope it comes to fruition. So they will be building like a huge solar manufacturing facility in Nigeria, somewhere in Nasarawa at Gora. And you also have recently, I think this was last year, a groundbreaking ceremony of about $250 million lithium factory. And we talk about a lot of key drivers. So lithium is a big deal when we talk about making accessible solar batteries and solar technology to everyone. So because you need batteries for your solar panels, you need batteries for your cars. And I think when Professor Onime would be introducing you guys to the kits that will be installed, he will talk about the kind of battery pack that he came with, and this is based on lithium technology. And then also, in 2023, Empower New Nigeria, so a renewable energy financier, is giving about $6.5 million US, and this will be done in Lagos. And this is the purpose is to deal with solar PV and batteries at 10 stores in Just Right Limited. So this is a company dedicated to bringing healthy groceries to the community. And so some of these kind of projects just tells us of, it can also tell us as a community here that there are possibilities for the kind of knowledge you're gaining here in terms of solar installation to be applicable in real world scenarios in Nigerian context today. If I'm going too fast, just tell me to slow down a bit. So there is also a launch of renewable energy investment platform for limitless energy. So these are all, and this is done by the Nigerian Sovereign Investment Fund, and this would be in Kano State. So a lot of the projects you can see is done across the length and breadth of Nigeria, in Kano, Nasarawa, Lagos, and different parts of Nigeria. And then, so this is something we should look forward to, potential launch of electric vehicle assembly in Lagos. And so we'll be looking forward to this, and this is 2023, 2024 projection. So we'll see how it goes. So all of these things I talked about a lot about renewable energies, but there are certain challenges that it will face. And some of these developments, some of the key developments are, like you talked about, the slow increase of renewable energies in the total final energy consumption. So I talked about the difference between looking at just primary energy consumption and the total final energy consumption. These are kind of important things you have to take note of when you think about energy. So there is a slow increase in this, and we need to kind of accelerate that. So we need to innovate in more sectors. We need innovation in more sectors, so for renewable energy. So we talked about cooling this building. So we have civil engineers here, we have different engineers here. So we talk about, like, when we plan our buildings, we should think about more holistic kind of planning to incorporate more renewables and to think about how to use renewables more carefully to help with these kind of things. So we also there is need for development of increased affordability when we talk about the markets, the infrastructure. So if you think about a lot of solar panels that we use in Nigeria are all imported. So if some of the initiatives, the big initiatives by the government is implemented where we can have solar facilities, manufacturing, distribution in Nigeria, then this can reduce the cost, especially for imported stuff, because Nigeria is actually very resource rich in a lot of things we need for solar technology. Now, I highlighted this in yellow, the lack of sufficient policy support and enforcement, and the persistent support for fossil fuels. Now, that's in yellow. The reason is because Nigeria is a fossil fuel producing country, so we need to use as much fossil fuel as we can. But we should also remember that we're not even producing enough fossil fuel to cater with all of every singular need that Nigeria needs to talk about. So that's why I made the distinction about primary and the TFEC, that we need fossil fuels for plastics, for petrochemicals, for chemicals, for various industries. So we actually need a lot of petroleum-based product for that. Until we find sufficiently cheap substitute for that, we still have to use fossil fuels. So we still need fossil fuels. But in energy generation too, we still need to think about alternative energy sources. And so there is, so we talk about the lack of support for policy and enforcement. So this is something that needs to be discussed at different levels, at the university level, at the governmental level, at almost every level. We should think about appropriate policy, like OAU should have a policy that talks about, let's say, tree replanting, let's say green zones. So we'll say, okay, this is the campus, we have certain green zones that we plant indigenous forests. So we don't want to replace indigenous forests or indigenous species. And so we have people from Botany, they should talk about, okay, if we're creating a green zone, it should be indigenous species. It shouldn't be just some different species that we just plant just for the sake of having trees or for those. Now, talking about policy, so the good thing is I saw this, Nigeria actually have some amendments that we are looking at. So you see the Impact of Electricity Act 2023 on renewables. So this policy is kind of notable because Nigeria is also thinking ahead as a country that they need to implement more renewables at a national level. So it means that the fact that we are an oil producing country doesn't mean that the country is not forward thinking in terms of policy to support this. Now, also there is a proposed passage of biofuels energy industry framework, and this is in Nigeria as well. So you can see the development of the biofuels energy industry in the country has passed the second reading stage at the House of Assembly, Representative of the Republic of Nigeria. So there's a lot of scope and there's a lot of framework, there's a lot of things ongoing. And I'd like to thank you guys for listening. This is the conclusion of this session. So we're going to go into the afternoon section. And before we go into there, are there any questions? And then do we have time to just discuss about what we've had? And yeah, any questions? Yes.
Thank you very much. My name is Inoroa Baywana. You've talked so much about the solar power, and I also wanted to look at the environmental impact that might bring. Because, for example, for any solar power system, the core of it is the battery. And battery, we know, is made from a lot of lithium materials and from materials that are not renewable. So what is the environmental impact assessment on that battery based on the fact that it's the core of solar power system? Thank you.
Does anyone have an answer to his specific question about the impact of the battery systems on solar power? an opinion.
So thank you for that question. Truly, in a solar installation, presently in Nigeria, we will need battery for backup. But depending on the design of your solar system, you could decide to go full solar without backup. It's a decision which you could make. But majorly, because of when sun goes down, you will need backup of the energy which the solar will produce. But you could design your system in such a way that you have more solar so that you could power your system. For the type of system you use, it might be the ones you will use in the day and not throughout the day. So it could be a sort of a decision. A decision will have to be taken in that regards. So lithium as a source of energy, which is as in the wattage to weight of lithium, is when I say wattage, when you see a lithium battery, the size compared to a sealed lead acid battery, you will notice a lithium battery has more capacity in reference to the weight. So that's why these days people are actually advised to go for lithium battery, and though it's more expensive than the sealed lead acid battery. So as I've said earlier, your decision to actually design your system for more solar or for backup will determine what happens in that sense. Thank you.
Thank you.
So the observation is quite very poignant, but what people try to do now is change the type of energy storage that you use. So depending on the size of your system, not in IoT situations now, but if you're talking about large solar farms, instead of having a battery energy storage system, you could look at having a flywheel energy storage system or a pumped hydro. So a flywheel, essentially, the idea is that you want to try to store the energy that you generate at a particular time. So if you use that energy at that particular time to do something else, when you don't have that energy, you can use that same thing to give energy back to the system. So in the case of a pumped hydro storage, for instance, you are pumping water up. When you don't have the energy, solar energy, you use that water that is damped to generate electricity back. So that's typically what is being used to replace the batteries in storage systems. But for small systems like this, they become tricky, and that's where I think what he was saying comes to play, where you have to just look at the size of the type of battery that you're using to store what. So that's also another observation.
All right, thank you.
So, I want to believe this impact assessment that you read, you extended to environmental impact assessment, but I believe there is always a kind of agreement between the manufacturer of the batteries and probably the service provider or the user to always return the spent battery.
Yes.
Yes.
Okay. Thank you. Yeah.
Sorry, I was going to say that interestingly enough, at lunch we're actually discussing something similar.
Yeah.
On the long run, everything we do as human beings have an impact on the environment. So eventually, it might be 15 years' time, we will get to know more about the impact of solar farms and solar energy harvesting on the earth. So for now, but based on what we know, this is where we are. Okay? So I was going to say that if I remember correctly, maybe in 2014 or 2013, Goodluck Jonathan, who was president of Nigeria, did release some energy policy which focused on solar energy. At that time, I was really very critical of it because I felt personally that we should, as Nigeria, focus more on wind, chiefly because solar energy is very poor in efficiency. So the conversion from the sun energy to electrical energy is maybe 20%, maximum 25%. Whereas wind, I felt, was much more sustainable, as in a technology we can maintain. Like you mentioned, solar panels are not produced in the country. If a solar panel goes bad, I don't think there's anybody locally who is able to do anything to it. But if you have a wind turbine that goes bad, the guy, the roadside mechanic who rewinds your motor coil or something like that is perfectly able to fix it and get it operational again. This is just an opinion piece. I think you asked for an opinion.
I think your opinion is kind of very valid, but wind would be more ideal for grid scale. Because if you think about, let's say I build a house and I put a small wind farm, a wind turbine, it's not going to work. So as a country, from a country perspective, because of the cost advantage, maybe locally we can have skills to build wind turbines and wind farm. But from a direct, simple consumer, it would be cheaper to just buy a solar panel for your immediate solution. So instead of having us import huge and build huge solar farms for grid-based. So I think there is, like we always say, there is always a cost-benefit analysis, and then you mentioned the cost-benefit analysis. So to look at a full cost-benefit analysis for battery technology, it's kind of very tricky, because I would always say what we do at my center is we take solar energy and we do water electrolysis. So we split water into hydrogen, then we get hydrogen. And part of the advantage of that kind of process is that hydrogen is expensive, so we can sell it as a value-added product and make a bit more money, because you can use hydrogen for fine chemicals, for industries, for cars, and we have high purity. So if you think about now using, so this technology, it allows us to use locally developed technology. So, and that's why I'm saying that everything has to happen at the nexus of country need versus adequate technology available at the country-specific level. So for Nigeria, I don't know if we have, I think some companies are trying to build battery manufacturing plant in Nigeria. I don't know the state or the level where it is. So at this point, we might start doing a lot of life cycle analysis. And then we have lithium in northern Nigeria, which might also help with this kind of projects or thinking. But the full cost benefit analysis is something you can take up like as a PhD project, or maybe a full-time research project. And then you can tell us in the next conference we have, maybe in 5 years' time, that this is how it is, and those complicated models. It would be nice to know. I mean,
Yeah, I think it's also interesting. Does anyone know if the OAU is sort of looking at renewable energy? Maybe, are they looking at solar? Are they looking at, I guess the guys who will know are not here. Yeah? Yes, okay, somebody has.
I think solar installations as a... Thank you, sir. As far as I know, solar installations in the university seems to be an individual faculty projects. You know, faculty of technology might decide, okay, I just need some solar system to power some aspects of the section of the faculty. Like where I come from now, the faculty of pharmacy, we decided our internet systems are always off, like the outage we had earlier, you know, breaking internet, whatever. So our alumni decided they want to, you know, fund that aspect, and we got some solar panel installed and batteries, like lithium batteries, supplied. So, and from then we've been having, you know, constant internet connectivity, because most of the time Intercool are always on backup. When light goes up, they are always on. So every other faculty that has backup will always connect. So as a university, I don't think maybe the university have started a project which is a holistic solar whatever, but I know of individual faculties deciding, okay, we want to power some aspect of our faculty to do one thing or the other. So we might suggest that to them, and God helping us, something big might come up.
Thank you.
Thank you very much. So the scope for renewable energy is very open for both research, multidisciplinary research. So since we at a conference that talks about solar energy, I would introduce you a bit to the basics of solar energy. And how long do I have? It's 4 o'clock. So I'll try not to overburden you, but I'll go through a lot of basics. Okay, cool. So my outline would entail just looking at some basic knowledge about solar technology, which we already introduced in the talk about renewable energy. And because of the we are very diverse background, we just talk about some electrical basics, the different very fundamental laws that we are interested in when we talk about solar energy. Then we talk about the different characteristics of solar energy, and then some basic PV systems, and the different types of models, then a bit about batteries, inverters, and chargers. And then a lot of in-depth part of this would be covered during this course, where you have to see the batteries, the chargers, and the inverters, as well as the solar panel. So this is just basics. When you talk about solar technology, we have different kind of solar technology. We have the PV technology, which is kind of what a lot of us think about solar technology, just taking these to power our homes with solar panels. Then we have the passive solar technology, which I was talking about, that a lot of us get heating from the sun, we get lighting, even the solar radiation is sort of antibacterial. So that's why I remember when I was growing up, my mom would say, open the windows and open the doors and everything. And then you kind of think about that, that is just only light, but actually the radiation also kills bacteria, and is also very harmful to humans if you expose yourself too much to that. So it's kind of important to have that kind of light. Then we do a lot of solar heating, so both for homes and businesses. So I don't think it's very big in Nigeria for solar heating, but in a lot of countries, solar heating is being rapidly adopted, and this can take down your heating bill very, very nicely. Then there are other solar process heat, so where we use solar processes either to heat or cool commercial and industrial buildings. And this technology is still at its infancy in Nigeria, but is a well-established technology elsewhere. Then we can look at concentrating solar power, and this is where you have highly reflective plates that concentrate solar power, and then you can use that to form steam and then power a turbine. So this is ways that you can actually harness solar energy. So if you think about this, typically, so just thinking about just coming down further, we have solar cells, and then we have photovoltaics. I think there'll be more details that will be discussed about this. So if you think about a solar cell is just one single cell, but your solar panel is made up of lots of cells connected in strings or parallel, depending on the configuration that you are interested in for your solar panel. So your solar cell is called a PV photovoltaic cell, which converts your direct sunlight into electricity. And then the PV cell is the photovoltaics. It's just thinking about converting light, photon light converting photon light, taking advantage of photovoltaic effect. And this is an effect that was developed very long time, I think back in the 1930s or so. So, and then if you think about most solar cells we have today, and even the solar cell I think you'll be showing them is silicon-based solar cell. So this is like the most popular solar cell we have, and the efficiency ranges from about 16 to 25% of these solar cells. It might look not very good, but it's actually significantly okay. So there is lots of next generation solar cells that people are talking about, and there are lots of research that are being done on next generation solar cells. We have thin film solar cells and we have group 3-5 solar cells. So the group 3-5 solar cells are a different class of solar cells. These are named from their position in the periodic table. So, any questions so far? All right. So so I just talked about the group 3-5 solar cells and the next generation solar cells. In this university, are there any research ongoing in material science or chemistry or physics in trying to understand fundamentally the properties of solar materials or solar cells? All right. Okay, I guess none. Okay, no, it's fine. But if we talk about how Nigeria can come into this space of solar cells instead of just being net importer of solar panels, we can actually create, because there are lots of research ongoing in different places, we can actually create patents in the area of looking at next generation solar cells. So these are materials made from organic materials, quantum dots, hybrid organic, inorganic materials such as perovskites. And I'm quite aware that, I don't know if any of you have heard of Professor Fabian Ezema at University. Heard of him? Huh? Ezema at University of Nigeria in Nsukka. So I think he's one of the most highly cited scientists in Africa, not just Nigeria. And he's like a top-rated material scientist globally. So part of the research he does in his group is actually looking at next-generation dye-sensitized solar cells, organic and inorganic solar cells. So these are some of the materials research they're doing. So in this kind of research, you can actually create niche areas that are where you can patent these technologies that would be beneficial local to Nigeria. So if you can patent this technology, then you can discuss at a high level, can we actually start developing this for Nigeria and Nigerian market? So in principle, this is possible to do. Sorry for the typo in the title. It was supposed to be passive solar technology. So if you think about passive solar technology, like I was discussing earlier on, there are certain things and certain aspects that are important when we talk about passive solar technology. And this is something that people barely talk about, is that we can actually create passive solar heating, we can create passive solar cooling. And some of these passive solar cooling systems, you just take advantage of the sun and create systems that allow for passive solar cooling, passive solar heating, especially in Nigeria. And this is kind of very important in Nigeria because we have very high solar irradiation based on where we are located. And I was discussing with Onime yesterday, and we were talking that IFA is about 6 degrees to the equator. So if you are 6 degrees to the equator, so it means that we really get a lot of the sunshine here. And then you can also think about passive solar design such as aperture, thermal mass and control. So I think this speaks to more like the engineering and the civil aspect of a building. So you want to say, okay, if I can create a passive control, so passive controls are like your concrete walls. So if we build very thin concrete walls in different parts of the world, what is the size of the concrete wall we need in this part of the world to be able to thermally regulate our building to have proper cooling? And sorry, I didn't put some pictures. If you think back, we built mud houses, and this mud houses actually serves as big thermal control. And then you had this thatched roof, and generally the places are a lot cooler. So this is technology that we should have translated today, and we should have tried to understand better and try to use them in a better way. And then if you think about the way we used to cool our water, when I was growing up, my grandma had a big clay pot, and the water was forever cool. So this is, we could actually use some of these, and this is understanding solar irradiation and how we have heat transfer and mass control. And so this speaks to the multidisciplinary nature of solar technology. Yes, in principle, yes, I think so. we can actually build huge clay pots where we can have, yes? Yeah, in principle, we can actually build huge, so not necessarily clay pot parts. So we can build, like we are here in Ife. Nothing stops us from having like, okay, let me use the term very colloquially, a watering hole where you have a big clay infrastructure, and then you can store a lot of beers there, and then it's like really, really cold, and people can come and get that. And this can actually, and this can be something you can sell. You know, when I say sell, you sell it more like an idea, a recreational facility that if I come to Ife, there's a big clay facility where the beers are super cold. And then maybe we can have multidisciplinary research that will be conducted in this. And I think this kind of idea is very radical. And it might actually work in, I recently attended, so this is just a bit of a digression, a US-Africa meeting. So the US Army is interested in funding radical designs. So this kind of design might be something that you can sell to them, and then it can be applicable in places where there is no readily available technology where the US Army is. And so they're able to fund basic research, and they have, I think, about $5 billion to fund basic research. And a couple of people I know have been beneficiary to this research award. And so maybe the OAU or scientists in the OAU can put up a research proposal to develop something like this in conjunction with Professor Onime that suggested this. Yeah.
Yeah, okay. My name is Solomon from Ethiopia. I see in Rome. In Roma, most of the time there is a free water which you can get everywhere. It is really cold. And probably the idea what you were saying is probably when it is passing through it. I heard that it comes from the other parts of the city, and then it passed through the rocks, very cold. So when it arrived there, it's really cold. It is free, anyone can drink, and probably the idea what you mentioned is already applied there. I don't know.
Hello. Oh, okay. So we're talking about, all right, cool. So we are talking about passive solar water systems. Now we have actually solar water heating. So I was able to show a solar heater here. This kind of is appealing because currently I'm trying to install one. And the reason is that in Nigeria, we don't bath with a lot of hot water. For those that do, it's something that you should think because it's not that expensive to install. And then you can actually install it with your already existing infrastructure. And it's actually really cheap. And this just turns your sunlight into hot water, into thermal energy, taking advantage of the thermal reflectors in the system. So you're just collecting thermal energy and using it to heat water. And the good advantage of these is that it reduces our utility bills, which is kind of a problem. And for places where you don't have a lot of electricity all the time, so it means that at any point in time, you always have guaranteed hot water either for you, for different systems. And so this is kind of some aspect of solar technology. And this is just made up of 3 components, as you can see. You've got your solar collector here, you've got your hot water tank, and then you've got your insulated piping. So there'll be some pipings that are insulated. And talking about cheap technology that can be made, this is some kind of technology that a big institution like OAU can say, okay, why don't we devote certain amount of funds to either the engineering department or to certain department to try and develop this kind of technology locally. And then, yes, okay. So this system is sort of similar to your photovoltaic system, but in terms of photovoltaic system technically produce electricity, but this just uses the solar radiation to heat water. Okay.
Sorry, can we use the water to make amala or something?
Obvious.
Boiling water. You can boil the water.
I mean, in principle, you can boil the water, but so what we do in this kind of systems is you also have a temperature control system for both your solar, but this is more for the newer systems that are industrial. So you want to keep the water at a certain temperature because the tank also, you have to worry about the tank not busting. So in most cases, for this kind of systems, we don't take it to 100 degrees. Because if you want to take it to 100 degrees, then you have to use thicker and more expensive container for your tank, for your storage. So I don't think, so the commercially available one, you can't boil amala, but for the research ones, the ones that we're building in the research lab very soon, I don't know who would build that. I think we can make amala. Yeah.
I was thinking of the local food seller, you know, if we can cut down her energy bills or energy consumption at the end of the day. Yeah.
Yes, I think for specifically for Nigeria, with the amount of sunshine we have, we can build specialized system for. So this would not just be. A lot of times they build this to replace your water geysers. So most times you don't take it to 100. So we can actually build specialized systems that you can maybe take to 100 degrees and monitor the temperature. And then if there's, so some of these systems as well, you can actually couple them with your grid. So you have electricity to heat up the thermal couples inside, as well as solar, so you can keep it at specific temperature all the time, if need be. So I think we can develop clever systems to solve uniquely maybe Nigerian problems. So just a basics on electrical basics, and I believe that most of you here are more vast and more learned in this. So we'll just, if you feel free at any point to stop me and correct me, just raise your hand or just speak up. So we just look at just this so you can see is direct and alternating current, very basic stuff, Ohm's law, power and energy, power factor and cabling size. So do we all understand direct and indirect current? Direct and alternating current, sorry. Is there anyone that does not understand direct or alternating current? Who? You don't understand? So what do you think it is from what you did in secondary school? Well, what do you assume is direct? The one says direct, another says alternating.
It is direct.
One can kill you, the other one cannot. One can kill you, the other one cannot. I'm just joking.
Prof said one can kill me and the other one cannot.
I'm just trying to keep a lighter mood here.
Battery, this is battery. This is
How many people want to talk?
This is what battery.
yeah.
And then
The other one is alternate current. That's one we use in our day-to-day 220 and everything. But both will kill you at large current. Yes. In fact, the DC is more dangerous.
I honestly don't know which is more dangerous. That's a disclaimer. But I know I've seen people die on transformers when they go to steel wires.
Well, we have the guys from electrical engineering here. Electrical engineers, what can you tell us?
Dr. Bipe.
Okay, basically, I think the current, if you have a large current through your blood, it destroys, kind of ionize your blood, destroys the person. I mean, it kills the person with few minutes.
All right.
So if you have a low voltage, large current can still kill.
All right.
Yes, so it's the current that kills, not really the voltage. Any other?
DC signal does not have frequency. AC has frequency.
All right. Okay. No, thanks very much. And he just said DC no frequency, flat line, AC frequency changes, sinusoidal wave. So which is true. So you see, I'm saying I'm not an expert. A lot of you understand this better than I do. So when you think about
direct versus alternating current. Different systems generate different kind of current. So generally, our solar panels have been programmed to generate a certain type of current, and this is why we need to take ourselves back to some of the basics to be able to understand what is direct and versus what is alternating current, so that when you see the solar panel and you see a certain rating, you would understand what kind of current or what kind of voltage is coming out and why it's important. So like you mentioned, it's true. We have, for our direct current, we have our batteries and our PV panels, our power supply outputs for laptops and cells. So if you think about, if you have your laptop, you always have a charger, your phone, you have a charger, and if you think you have a small transformer that transforms your alternating current to direct current. And so they use those kind of current. And then if you look at the alternating current, you have a positive and negative voltage terminals that do alternate. And then we use it, and then like you mentioned, you said NEPA, our 230 voltage for single phase alternating, and then we have the industrial 400 volt, so which is 3 phase. So just basics of Ohm's law. I think this is quite important because you need to calculate your power rating. So Ohm's law is your voltage, your resistance, and your current. So you can have V is equal to, you can have your impedance as well, which is for your AC circuits, and resistance for DC circuits. So for your DC circuits, you look at the voltage is equal to R times I, which is your current. And then we all are familiar with Ohm's law, right? Yes. Oh, good.
I think it's VIR. Yeah. So V equals to IR.
Yeah.
That's voltage equals to current times resistance.
Okay. All right.
So what is the implication of the Ohm's law? So the implication of the Ohm's law is that your voltage, you can say it's fine, is directly proportional to your current as a function of the resistance. So, and this is kind of an important thinking when you think about your cabling. So that's why we're going through the basics. So if you think about a certain cable will have a certain resistance to current. So if you apply a voltage, or if you apply a current, you'll be able to determine how much voltage we have. So this is kind of some of the important things that we need to take away from these laws. So also power and energy are kind of important. So power is usually measured in kilowatt. So, and this kilowatt is very important, while energy is something that is kind of really important, which is what you get from PHCN. So they will tell you that your energy consumption, because they calculate your energy consumption per hour as a function of the time. So for every time as you use, what you get is energy. And this is what is also important when we think about our solar panels. So your PV ratings will be in your kilowatt hour. So you can have peak rating, so the theoretical rating as standard test condition. So a lot of times when we think about our solar panels, you see we always say that the solar panel has, maybe you see the manufacturer will say 25% efficiency. Now, this 25% efficiency is the rating from the manufacturer. Now, when you use the solar panel, there are a lot of other factors that can reduce the rating for your solar panel, and then I think I'll talk about that in subsequent presentation that would help you properly account for these losses when you're thinking about that. So we can see that power, we can calculate power as a function of the voltage and the current. So you talked about voltage and current, and how the relationship between voltage and current, and how one kills you, the other one kills you as well, or something. So another thing that is interesting is the power factor. So the power factor looks at the power factor angle is the angle between the voltage and the current phases. So you can technically have sometimes out of phase in your transformer system. And is there anyone that is really, we are our electrical engineers? Is Yes, so would you be able to tell us about this power factor?
Thank you very much. The power factor issue relates to the real power and the apparent power. Now, because most of your, like for example, the transformer or even generators, they have coils, and coils, they have inductance, so they create reactive energy. And how that reactive energy is not really consumed. So the ideal thing is to reduce it as much as possible. So if your coils are made of inductive reactant energy, there's a way you can also cancel that. It means you need the negative reactive component. So that's why in power stations you have this capacitive bank to kind of counterbalance that. And also for big industries, to kind of create an incentive, the government can also give a tariff if you can locally install those materials in your site to reduce the reactive power. So those are some of the ways you have it. But the ideal thing is to have it, so the smaller the reactive energy, the higher your power factor. Now the idea is to go to 1. So the higher the power factor. Right? Thank you. That's not, it's not good for it. It's just going to damage it. So that's why it's not advisable to run it on solar power system where the demand is always fluctuating high and you from peak to middle, and all that. Yeah. Thank you.
Thank you. Like our colleague mentioned, if you have some of these new inverter-based air conditioners, then you can actually use those with your renewable energy generating systems. Okay. Any other questions or comments? I mean, the idea is to have a discussion. If there are things you've experienced or noticed, bring them up and we talk about them.
Adiwoyin Adilo by name. For the recording. Adiwoyin Adilo by name. If that is the case, is there no technology that can build an efficient solar panel so that all these gadgets can be used, effectively?
They are. We have DC dual inverter, DC inverters, AC that well lower consumption, and the idea is that their compressor does not, although the starting current is high, but not as high as the former one, and it doesn't cut off. You understand? It keeps working. So, for example, the dual inverter AC does that. So you can use that with your solar panel, convert to, you understand? So that's just it.
Then in that case, another question, because we are clamoring for, environmental friendly, renewable energy, all this stuff. And we now say that those gadgets, they are expensive, even for, average person to get, because I saw one, what is it called? Solar car at Oshogo. In fact, when you see that car, it's highly efficient, very small, and it's really beautiful. But when we asked the amount, so it was like, guy, is the amount, even every one of us that we are assessing the car, once we are get the amount, everybody was like, we are just moving. So I was like, it's beautiful, it's okay. And as an environmentalist, we preach this. But the amount is highly, So how can we and how can the technologists generally make this thing available for common men? My guy is now doing like this.
Well, no. The reason is this. Due to the fact that research is still going on them, and if you look at this PV solar cell, they are not just done they are done in a very clean environment, in such a way that what it entails to produce them, is very, very expensive, and it's not easy. You understand? So definitely that's why they're expensive. So I think research is going on also that's why you say going on green, it's not cheap. And research is also going on, and in such a way that government can also subsidize some of these things to help citizens. But presently, they're a little bit expensive.
Okay. Thank you. So we have comments coming now, so I'll work my way across. Yes, I think this one is for the people who are recording on the laptop.
Okay, recording. Okay. It's quite funny when people talk about subsidizing this, subsidizing that. If you want to subsidize, you should be talking about subsidizing food, not scientific discoveries, technologies. For those of us who are staying in the university quarters here, if we are in Europe, none of us will be bringing car to the office. If we are in Europe, what is the difference between quarters and? But there is this mentality. My brother there was talking about the solar. The electric cars being very expensive. What can the engineers or technologists do to bring it down to the level of a common man? They won't do anything until research gives us, the technology, give us materials that we can. For example, what does it take to power that kind of a car? If we can do it locally, then it brings down the price. But you don't wait for Germany or US to produce something and then you want them to give it to you for free. Simply continue to trek and then allow those who have money to buy the technology. So, and if you don't want to do that, then we all, discipline ourselves to, live within our resources and then fund science and engineering to make sure that we develop technology locally. We are simply wasting our time. Nobody will tell you the secret of his or her technology. America will not tell you what is the general science, the general technology.